Hello, welcome back. We are continue to discuss tutorial question 1.1. In previous video, we already discussed about isotope notation. So today we are going to focus on interpret the mass spectrum, and then we are going to calculate the average atomic mass. Okay, and also consider we will finish chapter 1.1. Basically, mass spectrum is the output from a mass spectrometer. This is how the mass spectrometer looks like. What is the function of mass spectrometer? So it is a device that you can determine the number of isotopes, mass for each isotopes, and also the abundance for each isotope. A very general term and easy to understand terms that can quite similar with the meaning of abundance. We are going to use the terms quantity. That means how many of each isotope. Okay, the mass spectrum basically will be shown in the screen of the monitor. Okay, so how the mass spectrum will looks like? So based on the description here, it looks like a graph. Okay, so the graph looks like this. So as usual, there are the y-axis which represent the abundance, while the x-axis is represent the mass. Okay, if you still remember, the meaning of abundance is the quantity. Okay, however, sometimes the mass spectrum also can look like this. Okay, so generally also the same. Here is represent the abundance, and then here is represent the mass. So we are going to use this information, abundance and also the mass, to calculate the average atomic mass. Okay, now let's check out what is the information that we can look from the mass spectrum. The first one, the number of peaks represent the number of isotopes. Okay, so let's say in this mass spectrum, we can see there's three lines. So means that this element have three isotopes. Okay, so let's represent the element with the symbol X. So we try to write down 3x first. Okay, then what is the next information? The height of the peak is represent the abundance. So from this mass spectrum, you can see the higher the peak, the greater the abundance. Okay, so abundance is the quantity. So that's why we cannot put any information of the quantity into the isotope notation. Then what is the next information that we can obtain from this mass spectrum? This mass spectrum is the mass of the isotope. Okay, mass of each isotope is represented at the horizontal axis. Horizontal means x-axis lah, melintang. Okay, so since this is the mass, so if you still remember when we mentioned about the mass will be represent the neutron number, okay, in the isotope notation. So neutron number, so neutron number is represented by the symbol A. So means that 70, 72, and 74 is the neutron number for this element X. So I will put the number 70, 72, and 74 at the left top corner. Okay, after knowing how to interpret the mass spectrum, so now we continue with the part of calculation for average atomic mass. This is the formula that you should remember. So this symbol represents the sum or the total, jumlah. So this Q is represent abundance, while the M is represent the mass. And the small I here is represent the isotope. So for me, I will remember this formula like Kimi-Ki. Okay, means that the sum of Kimi over the sum of Ki. Okay. Later, you may notice there are two terms always appear in your questions. One is average atomic mass, and the other one is relative atomic mass. Basically, average atomic mass and relative atomic mass, the value are same. For example, let's say I say there is 23 AMU. So the relative atomic mass will become 23. So the difference between these two terms basically is the unit. So like previous slide, average atomic mass, the formula to find out is the sum of the kimi over the sum of the ki. Okay, so when we look at this formula here, why we have three number here is because magnesium have three isotope. This is the mass for isotope magnesium 24, magnesium 25, and magnesium 26. While 63, 8.1, and also 9.1 is the abundance, the Q. Okay, this is the mass. So, and then we divide by the quantity, so we will get the average atomic mass. If the question asks us to look for the relative atomic mass, in the calculation part, basically we have to do one more step. Okay, this is the formula how the unit of AMU can be cancelled out. So here they mention the average atomic mass of one atom of the element divided by 1 over 12 of the mass of an atom carbon 12. So carbon 12, the mass of one atom carbon 12 is 12 AMU. So average atomic mass of an atom of the element is this is the one that you find from the average atomic mass. So let's say this is the 24.33 U over 1 over 12 times 12U. So U and U cancel out. 1 over 12 cancel out with the 12. So finally your answer is 24.33. So you can see the number is the same, but the unit is cancelled out. So this is the difference between average atomic mass and also relative atomic mass. Okay, after get some idea, then now we are continue with the tutorial question. We start with question number 5B. The mass spectrum of magnesium is as follows. So here we have intensity, and horizontal axis is mass. So reminder, the intensity can be in terms of percentage or can be in terms of ratio like this. They will just give us the number. Okay, now let's check what the question wants us to do. Write the symbol. So the symbol here basically is represent isotope notation. Okay, and then another keyword is each. So based on the mass spectrum, we have three isotopes. So we are going to write magnesium 3 times. Okay, this time we didn't use the symbol of S because the question already mentioned it is magnesium. So we are going to use magnesium. Okay, and then we also already know the horizontal axis, the x-axis is represent the mass 24, 25, 26. All these are represent the mass number. Okay, so the mass number basically is refer to neutron number. So that's why I will put 24, 25, and 26 at the top left. Okay, so if this is your answer, you will not you are not completed yet, because from what we already know, isotope must contain the symbol, the neutron number, the proton number, and also the charge if provided. Okay, so in this case, charge is not provided, so we must have symbol, neutron number, and also proton number. So the proton number for magnesium is 12. Okay, all these three should be have a similar number of protons. Okay, then now we continue with question number 2. calculate the average atomic mass. Okay, from the average atomic mass, we have the idea that they supposedly will have the unit of AMU. So now we continue with number 2, average atomic mass equal to the formula that we remember just now is Kimi. The sum of Kimi over the sum of the Ki. Okay, so in this case, first isotope, the abundance is 7.9, the mass is 24. Second isotope abundance is 1, mass is 25. Wow. The third isotope is 1.1 multiplied with 26 over 7.9 plus 1 plus 1.1, and then will be equal to, when we press the calculator, we will get 24.3 AMU. Okay, let's continue with the question number 6. The following mass spectrum of zirconium. Calculate the average atomic mass. So when I read up to here, I already know that later my final answer supposedly have the unit of AMU. Okay, and then based on this mass spectrum, the intensity this side given now is in the percentage. So basically, we can know that if we want to convert it to percentage, later the Q can be equal to like 0.52, 0.09, 0.12, 0.14, and also 0.13 when I convert all these number in the terms of percentage lah. Okay, so I believe you can do it yourself, so I will not show you the calculation. So this is the final answer. Question number 7. The following is the mass spectrum for silicon and calculate the relative atomic mass. So when I read this one, the requirement of the question is mentioned relative atomic mass. So I will going to know that my final answer supposedly have not unit. Okay, and then the isotopic mass is 27.977, 28.97, 29.9738 respectively. So if you notice in this question, we have the mass which is with 4 decimal place. And then we also have the mass which is already round off in the mass spectrum. So if we have these two kind of mass, which mass we are going to use? So because we want to get the more accurate answer, so later when you want to use the formula Kimiki, the mass that we're going to substitute into the formula is from this part. Okay, why we do like this? Because this one will give us more accurate answer. Okay, so after we use the formula Kimiki, then you have to remember you have one more step to cancel out the unit of AMU. Okay, now we look at question number 8b. Naturally, argon consists of 3 isotopes, 36, 38, and 40, with the ratio 4.81 and to 1423. Okay, first question B1, they asked us to calculate the percentage abundance of each isotope. So basically this is like you calculate the percentage of girls in your class and percentage of boys in the class lah. Okay, so I believe you can do it yourself. So the answer is given here. Okay, question number 2, calculate the relative atomic mass. Okay, so I think all of you is very good in this aspect already. So because of relative atomic mass, so there is no unit of AMU. However, just for the reminder, then now you have two options. You already calculate the percentage abundance. In the question here, also given us the ratio abundance. So in between these two, when you want to substitute into the formula Kimiki, so basically I will still encourage you to use the abundance of the ratio. Why? Because this one is given in the question. Okay, and then this one is you do the calculate. Okay, just afraid that when you do the calculation, they may have some careless mistake. Okay, but then if given you this, if you substitute it wrongly, it also is the careless mistake. So will be depends on you how you are going to do lah. Okay, let's continue with question number 9. Chlorine have two isotopes, 35 and 36, and then given the abundance ratio is 3.127. So in this case, we can consider it is represent 3.127 over 1. Means for the chlorine 35 is 3.127, while for chlorine 37, the ratio is 1 only. Okay, and then based on the scale of carbon-12, relative atomic mass given is 34.9 and 36.9 something. Okay, so as we already know, we want to calculate the relative atomic mass. So final answer supposedly have not unit. Okay, so if you notice here, we have two mass here, 35, 37, and also 34.9 and 36.9. So the value that we are going to choose into the substitution is 34.9689 and also 36.9659. Okay, so first we have to calculate the average atomic mass of chlorine. Okay, so because of this one is atomic mass of chlorine, so here we have the unit. Okay, then some of you may say that, is it okay if I change like this? Change the average atomic mass here, I add on the term relative atomic mass, and then I didn't put the unit here. Okay, this is not correct. In terms of the calculation step, this is not correct. Okay, we supposedly have to continue like this with the next step. Relative atomic mass of chlorine equal to average mass of chlorine over 1 over 12 multiplied with the mass of carbon-12. With this formula, then only we can cancel out the unit of AMU and also 12, and then maintain the same answer but without the unit. Okay, now let's challenge the different type of question. Okay, come. When I briefly scan this question, okay, I can see that the final part of the question is asking us to determine the abundance of each isotope. Okay, so abundance, the symbol of abundance is the Q. Okay, come. Read through the whole question. The mass spectrometer analysis shows that isotopic mass for bromine 79 and bromine 81 is 78.9 and 80.9 AMU respectively. If the average atomic mass is 79.9, calculate the abundance of each isotope. So in this video, we only mention about two formula. So I think it's very obvious because this is the mass, and then this is the average atomic mass. So we know that the formula that we are going to use in this question is average atomic mass equal the Kimiki. Okay, so average atomic mass is given, and then the mass also given in the question here. Okay, so abundance is the unknown. So what's the question asks us to find? So and then in one formula, there is one unknown, so it is workable. Okay, next what we need to know is another concept. You have to always keep in mind that total abundance of all isotopes always equal to 100%. So for example, in this case, we have to do assumption. Okay, let abundance bromine 79 is equal to X% because we didn't know how many percent. So we put it as X%, Y%, P%, Q% also okay. Just an unknown. Okay, so and then based on the idea here, total abundance of all isotope always equal to 100%. So if abundance of bromine 79 is X%, so abundance for bromine 81 will equal to 100 minus X%. Okay, with this we already have the Q value. Then we can do the calculation using the formula. So average atomic mass is given 79.9082. Okay, and then abundance of bromine 79 is X%, and then the mass is 78.9193. And then total up with the abundance of 81, 100 minus X, multiply with the mass of bromine 81, 80.9163. And then over the sum of the abundance. Abundance for bromine 79 is X, and then abundance for bromine 81 is 100 minus X. So before we continue to do the calculation, you may notice that X and minus X can be cancelled out. So then now here only left one unknown. So when you do the calculation, you will get the final answer X equal to 50.5. So change it to the statement. Okay, you will notice that abundance bromine 79 is 50.5%. Okay, while abundance for bromine 81 will be 100 minus X 55.5, which is 79.5%. Okay, so this is the how you're going to do the calculation for this kind of question number 10. Okay, last question. Calculate the relative molecular mass of each of the compound below. So again, when we look at the terms relative molecular mass, so we know final answer, no need to have unit AMU. So how to get the relative molecular mass? Basically, we just need to total up all the mass of each atom. Okay, so 11A and 11B should be not a big problem. Okay, just want to highlight that here, when we want to discuss about hydrated molecule, so basically in the formula, you will notice there is one dot here. Okay, so at here basically actually is plus. Okay, when you want to do the calculation, you are going to use the operation addition. Okay, plus the mass of this 5 molecule of water. Okay, so I think that's all for this tutorial 1.1. We will see you again. Thank you.